Hi everyone. Hello everyone. So in this video, I'm going to talk about thermodynamics. Thermodynamics. So in this lecture, I'm going to discuss particularly on Hess law of constant summation summation of heat. Well, so what is this Hess law of constant summation of heat? So here I'm going to define what is a Hess law. Number two, what is its application? That means use. What is the use of this Hess law? In my previous lecture, I was talking about measurement of enthalpy change. Enthalpy change during the course of chemical reaction by using instrument called calorimeter. Calorimeter I was discussing. Bomb calorimeter. Bomb calorimeter I was talking about. Measurement of enthalpy change experimentally all the time is not possible. Hence, we use Hess law of constant summation of heat to determine the standard enthalpy change, energy change during the course of chemical reactions from their respective standard enthalpy formation formation of the reactants. So given in the table, let us look. So how Hess law can be used for determination of standard enthalpy formation of the products. So from their standard enthalpy formation of the reactants, so which are already calculated. Let me define what is Hess law. Hess law. Let me define first what this law says. So this law says that standard enthalpy formation of a reaction is equal to sum of the standard enthalpies. Standard enthalpy formation of reactions if the reaction is carried out, if the reaction is carried in several steps. So let us assume Hess law can be discussed in detail. So for example, A is the reactant that can transform into D is the product. During this change of A to D, standard enthalpy formation takes place. Formation will be taking place. A conversion into the D. The same reaction occurs in two steps. A transform into B, which is as reaction intermediate. Then delta enthalpy change, standard enthalpy formation will be H1, and B can transform into C, which is reaction intermediate. Then standard enthalpy formation of this B conversion to C will be H2, and C transform into D final step, because final step is the stable one. So standard enthalpy formation is H3 naught. That means the standard enthalpy formation of the reaction takes place A to D is equal to standard enthalpy formation of H1 plus standard enthalpy formation of H2 plus standard enthalpy formation of H3. If we sum up these enthalpy changes, so that is equal to the standard enthalpy formation of the reaction takes place in single step. That means during the chemical reaction, energy changes are constant. Energy changes is said to be constant if the reaction is carried out in multiple steps. But some of the enthalpy changes of the multiple steps equal to enthalpy change that takes place in single step is said to be Hess law, we can write. So it can be discussed in more elaboration by taking one example. So what example I would like to take here is that let us discuss one example: burning of graphite, solid graphite, in the presence of excess amount of oxygen gas to form carbon dioxide. Carbon dioxide gas it can form. For the formation of carbon dioxide gas, enthalpy formation of the carbon dioxide gas, standard enthalpy formation is equal to minus 393 kilojoules. Okay. Standard enthalpy formation of CO2. The same reaction can be carried out. Graphite, when it burns partially with oxygen gas, it can produce carbon monoxide gas. It can produce standard enthalpy formation of carbon monoxide is equal to minus 110.3 kilojoules per mole. This is the first step. This is the step 1 reaction. Okay, and in the second step, and in this first step, carbon dioxide is not formed. When carbon monoxide gas burnt completely in the presence of oxygen to produce carbon dioxide gas, which is the final step, standard enthalpy formation of this step is equal to minus 283.0 kilojoules per mole. Now, net equation we can derive from these two equations. This is equation 2 and this is equation 1. So now from these two equations, we combine these two equations, graphite plus half oxygen and half oxygen will be equal to 1 oxygen gas, and carbon monoxide is cancelled, and carbon dioxide is the product, gas is obtained. The standard enthalpy formation of the carbon dioxide is equal to if you sum up these two values, which is equal to minus 393 kilojoules per mole, we can get. That means here carbon is burning directly to form carbon dioxide and producing the energy is minus 393 kilojoules per mole. Where the same carbon is burning partially to form carbon monoxide, enthalpy change is 110. When carbon monoxide is completely burning to form carbon dioxide, enthalpy change minus 283. And by combining these two equations, we can get, so graphite is burning completely to form carbon dioxide. Net equation we are getting, which is equal to minus 393 kilojoules per mole. And from this, we can prove that by using this Hess law, we can calculate standard enthalpy formation. Enthalpy formation of the compounds also we can calculate from the known values. From the unknown values also we can calculate theoretically by using Hess law of constant summation of heat. Let us take one more example. Let us take one more. If you want to understand this Hess law, constant heat summation, so we'll go for one more discussion, one more example. We'll talk. If 1 mole of 1 mole of benzene C6H6, 1 mole of benzene undergo combustion at 298 Kelvin, 1 atm pressure or 1 bar pressure. Okay, 298. It releases energy. Heat energy. I'm writing heat energy. Heat energy is equal to minus 3268 kilojoules per mole. We get energy when it burning completely in excess of oxygen gas. Then it produces, since it is a combustion, it produces CO2 gas and water, H2O gas. It can produce water, it can produce, since it is a combustion process. So from this data, what we have to do, calculate the standard enthalpy formation of benzene. We have to find out. This is the question mark. C6H6. So the question is 6C solid, 3H2 gas to form C6H6. Standard enthalpy formation of benzene is a question mark. We should find out. So how to find this? Let us discuss. What is the given equation? The given equation is that 6C benzene formula C6H6 plus 13 by 2 O2 gas changes into 6CO2 gas plus 3H2O gas Then standard enthalpy formation of this reaction is given. The question is -3268 kilojoules per mole is given. So this is equation number 1. Okay. Now what we should find out, standard enthalpy formation of the benzene, we have to find out from this data, from this given data, we should find out. So this one, standard enthalpy formation of the benzene, we should find out from this one we should find out. So the given equation is this one. As we know that C plus carbon combine with oxygen to form CO2. When carbon combine with oxygen to form CO2, standard enthalpy formation of the carbon dioxide is -393 kilojoules per mole. But in this equation, carbon dioxide is the amount of carbon dioxide formed 6 moles. Then now I'm taking 6C and 12 by 2, 6O2, which is multiplied with 6. Okay. And next one is water formation. Hydrogen gas combined with oxygen to form water H2O. 3 moles of water in this equation, it is formed 3 moles of water. Then 3H2 and 3 by 2. So then standard enthalpy formation of this water already given. How much it is? -285 kilojoules per mole, which is multiplied with 3. Okay, so now and by combining these two equations, by combining this equation number 1 and equation number 2, if I combine, so I get 6C solid plus 3H2 gas plus 15 by 2 O2, 6 CO2 plus 3H2O. And if you combine these two values of standard enthalpies of the formation of this CO2 and H2O, then it is equivalent to -3218 kilojoules per mole. Okay. This is equation number 2. This is equation number 2. This is okay. Equation number 2, and the first equation and the second equation. Now the first equation, what the first equation says, C6H6 plus 13 upon 2 gives rise to 6CO2 plus 3H2O. Standard enthalpy formation is equal to how much it is? -3268 kilojoules per mole. And if we inverse this equation, if we inverse this equation, inverse of this equation, we can get inverse of this equation. We get the equation is that 6CO2 plus 3H2O gives rise to C6H6 plus 15 by 2 O2 oxygen we can get. Now from this above equation and this is and the standard enthalpy formation is equal to standard enthalpy formation of this value is -3268 kilojoules per mole. From these two equations, if we get net equation is that if you combine these two equations, this is plus value because so I did inverse of this reaction. 6C solid plus 3H2 gas, 15 O2 and 15 by 2 O2. This is cancelled up. 6CO2 cancelled. 3H2O will be cancelled. And C6H6. Then standard enthalpy formation of this benzene formation is equal to, if you combine this, we'll get -50 kilojoules per mole we can get. So standard enthalpy formation benzene has been calculated from its elements, standard enthalpy formation of carbon and hydrogen. So from this, the Hess law of constant summation of heat is proved with this. So for the formation of 1 mole of benzene C6H6 from its elements, from the carbon and from the hydrogen, so enthalpy change will be, standard enthalpy change will be is equal to -50 kilojoules per mole